Hello, everyone. Today I'm gonna talk about a challenge that I faced, and that was basically creating a printed part for a function that was described mathematically, a 3D function, z as a function of x and y, and one of my colleagues, a math professor, who wanted to teach her students about maximum points, minimum points, and saddle points, asked me to create a 3D printed part that has an appearance like this. Okay, so this function, which I'm going to describe it mathematically in a second, you clearly see it has two minimum points in blue, two maximum points in yellow, and then there is a saddle point here in the middle, right? So she said, if I can show something physically to my students in the calculus class when I'm teaching them about max, min, and saddle points of multivariate functions, that would be a really good idea. So she gave me this function, which is described by 7xy divided by exponential of x squared plus y squared. And this is kind of very similar to the function that you see on the kind of like the math work plot. Now, it's not exactly like that, but quite similar. So she said, could you print this for me? And well, if you have worked with SolidWorks and CATIA, you know that they have some functionality for this, but they are not really going to make it easy for you, because if you want to do anything like that in SolidWorks, for example, what you need to do is to go and create sketches, and you need to go to 3D sketches, and then in 3D sketches, once you create an x and y for a point, then the z for that point, so you see here I'm clicking somewhere x and y, then you have to make this z a function of x and y, and that only gives you 1 point. Correct? And then you need another point, another point, another point. In all of those points, you make z to be a function of x and y. And then the most important thing is the tessellation, right? So in order to show you here, what you need for a 3D printer is a mesh file, correct? So let me reduce the resolution here, and I show you that when you create a mesh file, what you have basically is the digitized surface, right? You cannot have infinitely many points. You only can have a finite number of points. And here you see all of these points that are connected together. Here they are connected by squares, but in most of the time when you're dealing with a 3D printer, every 3 points that you see, every 3 points are typically connected by a triangle. And this process of basically connecting these connecting every 3 points that are next to each other and creating an approximate surface using a bunch of triangles or any other form of shape like these squares, we call it tessellation. So really, if you want to do tessellation, now you have to create tons of these surfaces in SolidWorks or CATIA, and that's not easy. So in general, creating something like that in a CAD software is not super easy, especially in SolidWorks and CATIA, as far as I know. And what I decided to do is, well, I said MATLAB is perfect for creating this surface, right? So I can easily create my range for x and y using the mesh grid command. So here I'm going from negative 2.5 to 2.5 with increment of 0.1. So I am going to have about 51 points along x, 51 points along y, so more than 2,500 points overall on the surface. I generate the surface, I can see it, visualize it, but now the question is, when I have this surface, how can I convert this surface into something that I can import into SolidWorks, CATIA, or any other software, CAD software, and then I can process it and make it something ready for 3D printing. Of course, you know, this is a surface with 0 thickness, so you can never print this, so you have to do something about it. But I found this amazing file on MathWork File Exchange website called STLWrite. So all you need is to go on MathWork Exchange File Exchange, I'm sorry, and just look for STLWrite. If you have an account with MathWork, then you can easily download this file, and this amazing file will allow you to provide the name of a file, an STL file, a mesh file, and then you give it your X, Y, and Z points, or if you have faces and vertices, and it will write those X, Y, Z points into what for you? Into an STL file, and it does the tessellation for you, basically. You just pass it the points, it does the tessellation, give you an STL file. So here, when I run this code, it is going to give me a file called MATLAB surface.stl, okay? And I can see it here. If I go look at my current folder, you see there is this STL file generated called MATLAB surface.stl. And guess what? Now I can go into my SolidWorks or CATIA, and I can open this mesh file, because that's what the CAD software understands. Okay, now SolidWorks is not the best for importing STL files, but if the STL file is not huge, typically less than 40,000-50,000 points on the surface, it can import it. Now, if the number of points is relatively high, it imports it as a surface, not as a solid model. And this is a surface, actually, and that's what we wanted. So you clearly see all of the triangles that I mentioned, correct? So you see clearly the tessellation has been done using that STLWrite file. And if you want, you can remove the edges to see the surface a little bit better. Okay, so the surface is generated, and now all I need is to create a cube, a block, using this as its top surface, and then basically convert that now into an STL file ready for 3D printing. So let's say I have this guy, and I'm ready to make it into a solid part. Clearly, I cannot print this. This has 0 thickness. So now I choose one of these planes, let's say this front plane here, and I create a plane under reference geometry, which has some offset from this down below, so 1.5 and Philip offset. So now on this plane, I'm going to create a sketch of a rectangle which is bound to the 4 corners of this, so it falls inside this surface like that. And now all I need to do is to extrude this guy up, but instead of going a specific amount, I say up to surface. And for surface, I choose this to limit the top surface of the extrude. And guess what? There we go. Now I can hide this. And look, I got myself now a solid object with this guy being the top surface, right? And now I can go ahead and save this for myself as a new STL file, which is called MATLAB surface print. And now this guy is going to have 5590 triangles. The file size is 279 kilobytes, and it should be easy to print this file, right? So I can go to my Prusa slicer software. And now I'm going to import the STL file. So here it is on my downloads. It's called MATLAB surface print. So I can bring it, and if it has any problem, I can let Prusa repair it. And if the scale is small, I can. So this is in mils, so I can make it into inches or anything like that. Correct. And now this is good, big enough. I can give it any infill I want, and there is no support needed for this. I can give it enough of shells to make it thick enough, and then what? Slice, and then it should be good to go. Now here it takes a little bit more time in Prusa to slice it because of the top surface, because that's not something simple, but ideally it should be able to slice it, and you see it did. It could slice it for me, and you can clearly see different layers that are generated with so many shells, and it looks just fine. It captures everything that I wanted, and once this slicing is over and the G-code is available, I'm gonna go export it, print it, and done. And that's how you would impress one of your non-engineering colleagues, right? They ask for something and you make it happen. And that's the power of engineering, and that's the power of combining MATLAB with SolidWorks. I'll show you more examples about combining MATLAB and SolidWorks later. One of them is Sim Mechanic Linker, and I hope you enjoyed this video. Thank you.